Good morning, guys. So today we're going to talk about two different conversions in a different form of our quadratic. We're going to start with converting from vertex form to standard form. And you guys actually already know how to do this, but we're going to review the steps because it will be a review on our binomial multiplication and our combination of like terms. So it'll be a review of our polynomial operations from Unit 1. So just as a reminder, our vertex form is y equals a times x minus h squared plus k. And what it gives us is that vertex point, so the point where our function is going from increasing to decreasing or decreasing to increasing. And that vertex point is found at the point hk. The other things that our vertex form tells us is our transformations. So our A letter is going to tell us if there's a vertical reflection, if the function is pointing up, down, or if there's a vertical dilation, meaning that the function is stretched or it is made fatter by condensing it. It's also going to tell us if it's going to move left or right with the h value, and our k value is going to tell us if we're moving up or down, which is a review from what we've done over the past week. We are going into standard form, which is in the format of y equals ax squared plus bx plus c. If you remember from our polynomial operations part of Unit 1, this is the form that we typically see these in, and we are actually going to go to another form in a few more days too. So what the standard form tells us is the y-intercept, so the intercept along the y-axis, and that y-intercept is at 0c. It still has the value of a, which is the same in vertex and in standard forms, and that's still going to tell us if there's a vertical reflection, if it's pointing up or down, and the amount of dilation, if it's gotten skinnier or fatter, transformation-wise. But it's going to give us this new key indicator of the y-intercept at 0c. So let's start with this function, y equals 2 times x plus 3 squared plus 4. So by the indicators here, and what we know already is this 2 here, because it's greater than 1, or the absolute value of this 2 is still 2, and greater than 1, it's going to get skinnier. We also know, because this is a positive value, that our function is going to be pointing upwards, so it's going to look something like this. Our positive 3 is telling us that we're going to move to the left 3 units. And our plus 4 is telling us that we're moving up 4 units. So by these indicators, our graph, our parent function looks like this, but we said it was going to be skinny, pointing up, moving to the left 2 and up 4. So it moved to the left, moving to the left 3 and up 4. So it moved to left 3 and up 4, and we have a new vertex of negative 3, 4. Which is also hk. So now let's work with this function, and let's work on converting it to that standard form so we can figure out a new key feature, our y-intercept. So first, remember, when we have x plus 3 squared, that's the same thing as doing x plus 3 times x plus 3. Now if you use the method of distribution, you can go ahead and do that here. If you use the box method, remember, to do this binomial multiplication, we need to multiply x by both of these factors, x and 3, and 3 by both of these factors, x plus 3. So we get x by x, which is x squared, 3 by x, which is 3x, another 3 by x, which is 3x, and 3 times 3, which is 9. So that will give us 2 times x squared plus 3x plus 3x plus 9, and then plus an additional 4. Now, remember, we want to combine our like terms to make life easier, so we're going to combine these 3 x's and have it be y equals 2 times x squared plus 6x plus 9 plus 4. So we're getting closer. We're almost there. Our next step that we need to do is we need to distribute this 2. So if I distribute this 2 to all of my terms, I get 2x squared, then I get 2 times 6x, which is 12x, and then I get 2 times 9, which is plus 18. And remember, I've still got that plus 4. So we are so close to being there. All we have to do is add our like terms at the end here, 18 plus 4. And we get y equals 2x squared plus 12x plus 22. You'll note that I still have this 2 out front. So now we are in what we call standard form, which is y equals ax squared plus bx plus c, the constant of c. and our y-intercept is at 0c. So as you can tell, our a is 2, which is still the same a that we found when we were in vertex form. So our a didn't change. Our b is 12, and we'll talk a bit more about what b does when we're in class on Friday. And our c is now 22. So this is telling us that our y-intercept is at 0c. So our y-intercept is actually at 0 and 22. And let's actually graph that and look at it. So you can see here in the dotted black line, I've plotted my original function in vertex form. And we know based on that, and we talked about that our vertex is at negative 3, 4, because we moved to the left 3 units and we moved up 4 units from our original position of 0, 0. Now I'm going to graph our converted form that we just did the conversions. And we know we've done this correctly because as you can see, this green line is the exact same line or the exact same equation as our black line. So we have successfully converted it from one form to another. But now we have this other key feature. We said that our y-intercept, so where we're going to intercept the y-axis, is going to be at 0, 22, and there it is. So you can see how both of these versions and both of these forms are giving us some key indicators that we can find. So go ahead on your homework and start trying to convert from vertex form to standard form. There'll be another video for converting from the standard form to vertex form, which is a little different, but not too bad as well.